So let's begin. Because my iPad charge is very low, so I should start quickly. This is 25 to 21%. Okay, this is a second talk of mine, the process causality and non-commutative probability 2. So let's take an overview, see the overview. In Tuesday, we talked about this. Now, today, the talk is focused on this. So maybe more people is interested in the theme causality. So I think this is most, how to say, the important, more important talk than the Tuesdays. First, this is a card game, classical card game in Japan called Carta. And Carta is from Pedro's country, Portuguese. There is the notion Carta, card, the Trump or something, card, Carta. I think that Carta is from Portuguese, the term. Anyway, card, playing card in the Carta.
And this is a proverb of Japan. Now, this is makan tane wa haeru, and it means that seeds and so never grow.
If you do not sow the seeds, you cannot have the germination. So this is a key term. Yes, seeds and so never grow. It is very good proverb to represent intuitive notion of causality. So without cause, no effects. So this is a very intuitive definition of the causality. Note that this is slightly different from the determinism. Determinism says that if something, then something. But this without C, no kind of relation is determinism. Of course, you may think of this is just a logical counterpart, but it's not the truth because there is some kind of primitive notion of time. So this order matters. So this is a different notion. This formalism is in the Western philosophy context. To maybe?
Sorry, yeah.
No.
That's fine. It was me.
You need audio. Okay. Sorry. Okay. This formula is known in the Western philosophy from Hume and David Lewis in the modern era. But actually, there is a good long tradition even in the Eastern philosophy, like Nikaya, very old Buddhist books. We have this kind of formulation. And this is related to the dependent arising and emptiness, which will be talked by Melanie Nagarjuna. Many philosophical, practical, but especially in 20th century, after Greece, there is many debates about the concepts of causality because this philosophical formulation gives you many challenges. That is, if we take this very primitively, there is many counter example for the intuition of causality. Because we have no time and no charge, I omit the details of controversy, but there are various refinements to complement this approach by using sophisticated technique or something. But although there are various refinements, but they have not been universally convincing. Of course, there is application of causality, and of course, one of the supreme example is IIT itself. But the problem of causality, what causality is not solved. Someone even argue that some does not include me, even argue that such attempts should be abandoned altogether. But here is new idea. The problem occurs from the very seemingly small point. That is, this C or E is seen as some kind of point, event. And the relation, causality is a relation between events. This is a very naive basic idea which is unconsciously hypothesized. So, but interestingly, replacing this CE as a events to processes, sets to categories, then we have the very good generalization of formulation of this intuitive scheme. Of course, this maybe reminds you, if you are a philosopher, analytical philosopher, it reminds you the generalization of the process in process theory, so-called process theory of causality, like Salmon and Dow. But this is a more general kind of process because it is just an arrow in category. So every kind of process can be grasped as an arrow in some category. So possibly, maybe it is possibly related to the Whitehead's process philosophy and the terms prehension. It's a very universal notion, but anyway, yeah, I know this. I will, and this is a joint work with Jun Otsuka, Yoshi, and Hayashi, ongoing work and writing the paper about this GPT. But I would call Cat-GPT is a category. But today's talk is due to my own idea. But the paper will appear with some more, how to say, strengths, philosophical context. But this is my naive idea. Okay. So process and causality. So I start from the notion of process. But process is, any kind of process is okay. So you can think of the movement of elementary particles or the change of the Fourier or any kind of process is okay. But anyway, the physics or the IIT or every kind of process is allowed if it satisfies the axiom of category. So let's start with a very philosophical background. So we want to define the notion of proc-ms. Proc means a process. And we will explain what M and S means. Starting point is some system. For example, a seed is a system. A bottle is a system. A brain maybe is a system. The part of brain may be a system. You can choose the system here. System S. But to talk about the states of the system, we need the notion of environment. Environment is another system which is very important, which do the very important interaction with S. Our assumption is this composite system, S and E, has a stable interface with outside world. So why we use this kind of concept is we want to think of the change of state that is a relationship with S and E. So this should be, in general, not fixed. So the fixed thing is the meta, the relationship of the composite system and the meta environment. So, for example, seeds and some farms. This is system and environment. But this farm is affected by the climate or something. So this is meta environment. So if the climate or background condition is stable, then we can talk about the state or change of state or something. So then we consider all the state change, all the possible state change of S under this meta interface between the composite system and the meta environment. So this is MS.
So in IIT terms, probably, for consciousness, S is the complex, and E is the sort of sensory,
Exactly.
And then M is outside.
Yeah, exactly. So then you can think of this. So this is the starting point to define causality for S under M. So of course you can think of all the universe, but I'm a very pragmatic person. So just focus on each system under the environment with fixed meta interaction, meta interrelationship between the its environment, this E prime. Okay, so we assume that this block MS becomes category. So consider the all possible process as arrows. The concatenation of the process is composition. And the event, which is a kind of trivial process, is object. And associativity or blah, blah, blah. So we name this block MS. I know there is few mathematicians here, so for mathematicians, excuse that any category can be considered as this actually. So in this talk, also the past category of the directed graph, because almost all causality papers or something is depend on the acyclic directed graph or something. So directed graph generates a category as a free category that arrow is passed. It is a typical example in mind. Then the main thing is that given block MS, we can construct another category, caused MS, whose arrows are causality. So this is the main topic of this talk. So starting from some notion of process you want to analyze, then you can talk about the causality for that. So causality is some kind of a relationship between set of processes and set of processes, and intermediate by another set of processes. Okay. Construction will be shown soon later. And block MS itself may be considered as cause M prime S prime. That means there is a important another debate about which comes first, process or causality, because when you can think of these process, it is some kind of causality notion here. So some argues that the causality comes first and the process then comes. Okay, I am in a neutral position. You can select, but anyway, it becomes category, and then you can construct another meta category from the starting point. And also category algebra states, in Tuesday I talk about on cause MS, which play a fundamental role to unify causality and non-commutative probability. Because if the causality has a categorical structure, then you can talk about probability structure based on this causality relation. So let's go. Okay.
So for my question, when I think of the system S, should I be thinking of kind of any arbitrary system, or like a discrete automata system, or a system of differential equations? They all fit.
Yeah, they all fit. Is there any questions so far? Okay. So to define the causality, we need one notion, process in which A occurs. So intuitively speaking, this growing over jar, this is a process. Yeah, maybe you forgot that everything is process. So drinking water is actually not an event because it takes time. So everything is process. But we talk about if this is A, to do this, we must buy or take some seeds from somewhere and do that and watering or something. So these are in the flow of this process. So this flow is say that process in which A occurs. So this is the A is some kind of arrow. Then the arrow, which is composed by some S1, S0 in the category, is the element of A tilde. So A tilde is an extension of A by composing beforehand and afterward. Okay? Then the definition, how short way. Because we mathematicians use a very, very long preparation, but this is the theme. So please be relaxed. This is the main notion. So what is cause? What is effect? And this is ignored, usually ignored term, the causal condition. Let A0 and A1T be collection of morphisms, arrows, set of arrows in PROC-MS that satisfies the following condition. If a morphism S in PROC-MS can be written as A1 composition T, that means that this S arrow is like a A1T. That means here the process which occurs, this growing, and T, some T plus of arrows. Then you can find this is the process which this sowing occurred. That why T needs? Because only 1 minute before, there is no such process. You know that here you see the germination, but only for example 2 minutes ago there is no sowing. Of course, you need a time. Time means some processes are kind of, if the radish that 20 days or something, you need to wait under the very good condition. So if and also there should be the limitation of the possible processes, like other birds comes and do or so there is many scenarios, but if you choose some scenario T, then this goes, then we call this A1. This A1 is the cause. This this A0, the set of this kind of arrows is called cause, and this thing is effect, and this is a causal condition. The naming, let us explain the naming, the meaning. The above competition means that process in which A1 occurs through the process in T is the process in which A0 occurs. In other words, a process in which A0 does not occur is not the process in which A1 occurs via the process T. So remind you the example. Thus, in conditioning by T, when A0 does not occur, A1 does not occur is given the meaning. If the germination can be observed here, then if we look back far enough into the past, then there is sowing of the seeds. If the seeds are not sown, there will be no germination. It is exactly as the says goes, the seeds unsown never grow. So note that. Okay.
I'm struggling to understand fully the notion of process, in the sense that you said contrast with event, but it seems to me like a process like drinking water can be break down in, let's say, 5 arbitrary processes concatenated, right? And then this may be 5 more, and so and so I don't understand really not the definition, but just conceptualization of what a problem.
Yeah, one idea is zero paradox. You cannot divide everything into the point. One idea is. The more essential thing is that event do not have the notion of composition. And the event is the point. So identity arrows. So set. So you must set up another apparatus onto that. But if you start from the processes, no need for the outside.
You want to put this extreme,
Mm-hmm.
there are no events.
No,
It can always be formulated only with the morphism.
oh yeah, that's the point.
In some sense.
Yeah. Because identity arrows are identified with object, and you can forget about object actually. But this object is some kind of event. Event is something like mediating the different process, and maybe in that sense, event is important, of course. So the point is this: causal conditions. It is not the relation between two things, no, because just so the relation, of course, it's relation, but if you choose A0 and A1, there is many T's around here. So no only one arrow. So it depends on the choice of T that A0 is cause, A0 is cause, A1 is effects, is meaningless question without choosing T. Under the scenario, T, the A0 is cause and A1 is effects. So by changing T, the A0 becomes not cause or something.
You allow any kind of possible path.
Possible path.
Once you set up this path, then
you can talk about this is cause, this is So this choice of the T context is can be interpreted by 2 ways. That one is subjective one. Subjective one is you can imagine the scenario, and also this is related to the real action, intervention kind of action that you can exclude physically, that birds cannot come in like this. So the choosing the scenario, choosing the extreme cases, actual causality. But we don't have many time here, but you can think of these kind of flexible one.
Is it the same as counterfactuals?
Yeah, but counterfactual for processes under some relative set of arrows. So by ignoring this causal condition kind of thing, there is very easy to go to the paradox, because we should think this is cause, but this does not hold or converse. But by choosing this, almost all paradoxical example, as far as I know, can be solved.
I think I don't remember which paper in IIT, but IIT also said something like that, right? They talk about the counterfactuals, but counterfactual is a kind of condition in terms of systems, architectures, mechanisms. It's not like from A to B, anything goes, right? We're going from something that doesn't happen and then that's a very different kind of causal aspect. So it's constrained.
So I think I'm not so much know for details about IIT, but now is one of my most important collaborators. And there I know something about IIT, and I agree. I think that, of course, this is a little, sorry, a little different, but in the spirit, I think. Okay.
I don't think I really understand the concept of T. So imagine you're seeing us. I think I see that.
Oh.
After that, I see the same thing somewhere. But in summary, the seed was there. But in open, it is
Yeah.
right? And then if we take T,
Yeah, good question. But the point is, the causality is not a determinism. So the whether or not it sprouts is not the matter. First. And when it sprouts, we can talk about the sowing is causal or not.
which sowing is caused?
Yeah. But you know that there is some needs you need some days to start germination. So if you choose T as, for example, only one day. Yeah.
Then if it's already there, then A1, the germination doesn't occur.
But how do we know, or
I mean, your idea is probably another seed that replaced the original dead one. Might have sprouted and you just observe, right? Or something like that. No. Because the dead one can't germinate.
Yeah. In spring, we see the same.
Right.
We don't know which are the cause of that.
But if that doesn't sprout, then
Yeah.
what do you mean by
A very good question. But in that sense, you can shorten making the scenario short. Then short means that the possible, like 20 days ago or something you choose, then the spring sowing is not causal. So yeah.
Then it is understand that summer, seeing in summer is a cause of this.
But you can test. Because if you do not sow summer, nevertheless it may occur. Yeah, by random sample, randomized, for example. So, yeah, we will talk later. But anyway, you can test by no quality something. So to search the cause, the basic strategy is knock out something and see what can occur. Without it, yeah. So the simply observing a case where A1 occurs after the process of A0 does not tell us whether A0 is simply a precedent or a cause. In other words, whether A1 is a successor or simply an effect. So if we, this is maybe a little answer for you. That if you want to confirm this, we should investigate under various conditions T whether A1 occurs when A0 is prevented from occurring, which is nothing other than investigating whether the triplet A1, T, A0 is a causality mentioned above. So if we consider that the typical situation in which we cannot help but think about causality is when we want to prevent a certain process from occurring, we can see that this definition is also practical. When you really want to search cause, you need this kind of scenario. So far, we have been able to define the concept of causality for the category proc. Based on proc, we can define the category cause, in which causality is an arrow. In fact, if we define the object, domain, codomain, a very natural way that this is a law, this is domain, this is codomain, and the problem is composition. Because it is known that in the naive sense, the causality does not have composition. You know that problem of transitivity. There is such a very famous counterexamples, but nevertheless, the composition can be defined in this framework because of the theorem, a very easy theorem, but you can define this kind of thing. This is just the set of arrows which forms this from this, this from this. Then this is a set. But this is also, if these triplet are causality in our meaning, this causality in our meaning, then this is also a causality in our meaning. It can be proved. So the composition is defined and satisfies the associative law. And also for an object A, you can define the identity morphism. Here, this is just a set of all identity arrows or objects. Then you can see that this is identity. So we can have the category of causality for the MS. That this is cause MS. So the possible advantage of this Cat-GPT is one is, of course, fundamental non-determinism, non-trivial causality against determinism. Actually, in determinism case, the preceding and deterministic and reversible case, the cause effects is the synonym of precedence and follower. So this is very trivial case. But the interesting case for the causality is nothing but a non-deterministic case. Actually, this is in the beginning, I want to apply this framework to the quantum theory, and this is my another dream. But anyway, any causal theory should have this kind of fundamental non-determinism, and this is captured by our framework. And the most important thing is focusing on causal condition. Without that, paradox occurs. So this is a very important thing. And this is category, so you understand naturally related to the non-commutative probability because Tuesday I talk why. And a category maybe as a primitive notion of spacetime. Of course, the spacetime is some kind of epigenetic kind of thing, but there is you point out some kind of order structure or the action composition kind of thing, the very primitive notion process. And I think that space-time is nothing but the all possible processes for the system under the meta interrelation. So this is PROC-MS is a very primitive notion of the space-time. So then what is the category algebra over it? So in the real so-called physical space-time, it is nothing but a field and a quantum field because of non-commutativity. So I wrote some paper about quantum fields category algebra, but the most important thing for you is toward consciousness. I think that this kind of category of causality is very basis of consciousness. And directed acyclic graph itself is sub-diagram of this kind of causality. And putting on the probability information is equivalent to consider the category algebra or state of consciousness, like now's talk. And the category algebra and the state on category should be called the Corey algebra state of consciousness. So this is almost the last slide. The possible question is, of course, the possible advantage and disadvantage of the Cat-GPT. I will want to hear any kind of opinion. And maybe I cannot answer directly, but I will consider very much, and I will appreciate, of course, advantages, of course, but disadvantages also. So from quantitative, this framework is up to now, very qualitative, that without N or B under T is a kind of 0-1 kind of thing. But choosing the T and the measure of T will reach you some kind of the strength of the causality or something. So to put an arrow, some number is you can remind of the Tuesday's talk. Putting the numbers for the arrow is nothing but considering category algebras and the state on categories. So please consider the theory, model, or experiment anyway. But non-commutative probability and on categories as a good basis for unification of the causal and probability structure, I think. So of course, consciousness is the main target, but maybe if you have another interest about which causal and the probability is also important. So of course, we want to hear about the relation to IIT and the application to QSTR. So thank you for your patience.
Thanks for the talk. I want to kind of ask what I, for my course, is kind of the missing middle here. So category theory is kind of meta mathematics, kind of helping us understand structure. And then your example, your Schrodinger playing example, that's a metaphor. I'm wondering, do you have or does there exist a kind of a really fleshed out application, something simple like that? Elementary cellular automata, some very discrete, simple dynamic system where we can see, okay, what's the definition of S in kind of specific mathematics? What does T, how do I flesh out the arrows? Does that exist yet, or has that not been done?
Yes, exists. One is quantum fields. Quantum field is you can think of the starting from manifolds. You can consider the point as object and some smooth path or the causal path as arrows. Then the physical phenomena is a bunch of the processes. And you can talk about the causality relation between these processes, even in quantum theory, like Qstr-IIT experiment, for example. It's, of course, a non-determinism. But if you do not chip the injector, then you don't have the result, of course. But these kind of structures should be imprinted in the quantum field theory. So one non-trivial answer is the quantum field theory.
Yeah, but Rory, what you asked me was, it's not necessarily the this kind of super advanced original kind of application or things that you can know only through categories.
Okay.
Probably you also find that kind of the phenomena that we already know from other kind of
okay.
But category theory we can also describe it from scratch and so in a complete way. And if that's the case, then I suggest this textbook for category theory for scientists by Steven. And I learned it's really good. And there are lots of examples of the distribution of the thing that we know from a completely category theoretical way. And it's advanced version. It's called 7 steps for category theory. It's all of that line.
Okay, I think now the I think now the explanation clarified me what you really want to say. Of course, historically, category theory develops as a meta theory, but here we use it's not as a meta theory. It is just a starting point. Starting point means like I think one small category is very primitive than manifolds. So, for example, you can start from any directed graph. It's a very concrete one, So then you can construct very concrete category that is vertex is object and the arrow is path. So all this framework goes. Or the programming, the data type and the program forms category. So I don't know the implication, but you can talk about the causality on program part. Or so starting from the axiom of category, you can find a very toy model of the many category, and we can freely talk on the causality of any kind.
Yeah, that's kind of what I was saying, is just a toy model to, because my intuition, that's where I best
Mhm.
build my intuition. So I was
Mhm.
wondering if it's a good place to look for it.
Yeah.
Something that someone could do with a very simple system.
Mhm.
Yeah, and in fact, for me, the starting point or starting counter of the category theory and for during the harmonization with this also all happened after I graduated from university and after postdoc, right? So to me, what was very kind of a reflection was that pretty much everything that we learn that we usually read and think about in standard theoretical thing is actually based on most set theory. The elements is a fundamental thing, and then sets of the things is the description, and then how to describe transformation of that to the other is a fundamental of all the logic. But there isn't a separate kind of the philosophy to start everything from category. And that way of the redescription of what we know, I think that feels much more richer way, also feels better way to describe the body. The body as starting from set theory feels really weird to me. And then that is sort of debate that we have in the head of stone a couple of days ago, right? Like starting from point of the warrior to think about inspiration is weird to me, but starting from relations and then go down to what we can talk about transformation of sets of relations to another one. It's more rich and more natural, I think.
Thanks.
So other questions or comments?
I'm just wondering, do you have if this type of causalities of category theory has an addition to resource theory? Or the things involved with transformation? Than just causality,
Yeah, related, and in this framework, I do not assume that the category is monoidal category or something, but you can construct the monoidal category from this kind of category, and you can really use that kind of framework. It is also Jun and me wrote some papers.
No other question or if there are any other questions we are asking now, let's restart from 11:10. Mark Bill, or if you are about time, we change that to sorry, it's kind of related.
You said one sentence, and I forgot it, and I wanted to double check if you didn't forget it.